So a multidimensional array. One-dimensional array, a single-dimensional array, you could picture it as a column of values, you know, a whole bunch of rows. Like if you only had one column in a spreadsheet. And so the elements can be accessed using a single subscript. A multi-dimensional array requires two subscripts, you know, a row number and a column number. And then there are, you know, a two-dimensional array requires two values in order to access it, a row and a column. A three-dimensional array requires three elements in order to specify it, three index values. So you can also call a rectangular array a matrix or a table. And you might have a 10 by 5 array. 10 times 5 is 50, so there'd be 50 elements, you know, 10 columns by 5 rows. Consider it similar to a spreadsheet. So here is a two-dimensional array allocated to be 4 by 3. And guess what? Y'all who have learned C++ and Java notation are going to learn a different notation for allocating two-dimensional arrays. But we'll get there. So this one's got 4 columns and 3 rows. And here's how they declared it with an initializer list. And if you look at this, this looks a little bit odd, but if we add some braces here, or I mean if we move the braces over so that it looks like this, you can kind of see what's going on. I think I goofed that. I definitely goofed it. Each row is its own array, conceptually, and when you declare it with an initializer like that. The whole array is declared inside the curly braces, and then the inner array consists of single-dimensional arrays, one per row. Now if you look at it, then you might wonder what would happen if you declared one of these to have, you know, like 5 values, and one to have 4 values, and one to have 3 values. Is that going to break it? No. It actually will let you create a two-dimensional array where the length of each row is of a different length. Now, are we going to do that too often? Probably not. We think in terms of, you know, where we have the same number of, you know, columns in every row. Do you have to allocate your arrays with an initializer list? No, you can specify. I want a 10 by 4, or I want a 5 by 3, or whatever. Again, they keep demonstrating how to use the initializer list. Don't want to do that. I want to see how to do it using an allocation. Okay, I said the syntax was different. I'm not quite sure it is. What this is saying is double, and then if we've got 2 square brackets rather than 1 to indicate that it's a two-dimensional array, tickets is equal to new double, and in there we're going to specify the value if we're not, the size of the array, if we're not going to allocate, you know, using an initializer list. Alright, I really wanted to show us allocating the two-dimensional array using a new command. And of course it didn't. So I could go grab the book, or I can Google it. I like Googling it. So, allocate two-dimensional array in C#. Like that. Can you see what I mean about the syntax being different?
Yeah, you can't, the way they declare it, it's weird. And that's actually on the Java test, too.
Yeah. So, to me, this conflicts a little bit with what we were just looking at that said that we were going to allocate our two-dimensional array in this syntax, where we used, where'd it go? That in order to allocate it. So we're going to play with both. I know I just had y'all open up that solution file, but let's close it. We'll come back to it and just do a normal one. So console application C#, whatever. We know how to allocate a one-dimensional array. Int whatever 1D is equal to new int 10. How about a two-dimensional array? Int, square brace, with a comma between them, 2D is equal to new int 10 by 10. Seemed like the PowerPoint was indicating I could do this. I understand what they were doing now, I think. $2D2 is equal to new int 10, 10. Yeah, that's what I thought. All right. This is the correct syntax. Right there. And I'm sorry, I need to zoom in. Here we have created an array. It's one dimensional. Here we have created an array that's 2 dimensions. Now let's iterate through this array to print it out, but it's going to all be zeros, right? It's not going to be real impressive. So for r is equal to 0, r is less than the we need to know how to determine the length of the array, the number of rows in the array. Alright, I've decided to change my two-dimensional array to be 5 by 10. So we have 5 rows by 10 columns. And there's always more than one way to iterate through an array. We could use for each. For each would work in this case too, but I just want to use an old-fashioned for loop where we have a row and a column indicator. Now we need to know how many rows there are. There's a way to get the number of rows. It's the getLength property. I'm just going to declare a variable to hold the number of rows. Normally I wouldn't do this, I just embed it in a for statement, but the number of rows in it is equal to the array name dot getLength, and the getLength method takes as its argument a number. And if you say 0, it will return that 5, which is the number of rows. And if you pass in a 1 instead, it'll return 10, which is a number of columns. And if you had a 3-dimensional array, you could pass in 2 and get that third value. Okay, so that's the number of rows. And then number of calls is equal to 2d dot getLength parentheses 1. And if we printed those out, which why not? Console.WriteLine rows equals placeholder 0, comma, calls equals placeholder 1, and then print out num rows and then num calls. It ought to print out 5 and 10. Start without debugging. There we go. Rows is equal to 5, columns is equal to 10. So that worked. We have the number of rows. We have the number of columns. Notice that's a little bit different than how you were doing it in Java if you did it in Java. There are other ways of doing this. You could get each array as its own reference, each row as its own reference, and step through it with a for each loop. But we want to change the values. We're actually going to, we're going to run through this again and then change the values, maybe to random numbers or something, just to be fun. So for int r, or row, but I'm going to, for int rows equal to 0, row is less than the number of rows, row plus plus, and then nested inside it, for int column is equal to 0, columns less than the number of calls, column plus plus. Let's print out that element. But let's use right rather than write line. So console.write, let's just write the value out. So inside our quote, string place 0, colon, and I want each number to occupy like 4 spaces in the screen. So there we go. 0:4, end quote, comma, and then that value. Our array is called 2D. So 2D, square brace, row, comma, column. And again, notice the notation there. In Java, you specified 2 pairs of index values, each in their own square brackets. After we printed out an entire row, we want to print out just a character turn to go to the next line. Console.writeLine. Good enough. Now, since we haven't put any data into the array, it's just going to be all zeros. I really need to put my read key at the bottom because I keep clicking debug. All right, in this case it was all 4s. Excuse me. Is that a debug value? Are not arrays all initialized to 0 when we do this? Well, let's change one of those values.
Change your that 0, your console.write maybe. I don't know.
Yeah, do I have that wrong?
That could have something to do with it.
Foo. All right, so I've clearly got the wrong syntax there. I'm going to do it just like it was a floating point number with 0 decimal places. So I'm going to change my placeholder to say placeholder 0:F0. The 4 was being picked up as data, and so it was printing out a bunch of 4s. And I'm getting real tired of messing it up, so I'm going to add a console.read key at the bottom, console.read key, because I can't reliably remember to hit the run without debugging. All right, now we've got all zeros. They're not spaced out to the width that I wanted, though. Why is this? So I forgot to put the comma in as a width specifier. So 0:4. That means it's 4 characters wide, and I want it formatted as a floating point with 0 decimal points. Honestly, if I took that :F0 out, it would print it as an integer, which would be just as good. All right, now we have our 5 rows followed by our 10 columns. Very good. Let's store a little multiplication table in here where we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have 1, 2, 3, 4, 5. And then all the inner numbers are, you know, the first value multiplied by the second value. Let's figure out how we're going to do that. I mean, yeah, we could just, you know, fill it full of random data and print it again. Let's figure out how we're going to do that. So what we're going to need to do is we're going to need a nested loop that fills in the values
Could we just make the first row? Oh no, you don't want to hard code it though, so you can hard code the first row.
Well, we could sort of hard code it.
Just do 2.
Why don't we set the first row to the values 1 through 10, and then the first column to 1 through 5, and then doing the rest of these would be pretty easy. Now maybe this isn't the clearest way to do it, but I'm willing to give it a shot. All right, so let's fill the first row with the values 1 through 10, or whatever the length of it is. So the first row, whoops, wrong one. What is the row number of the first row? It's 0, right? And then the column number is going to count from 0 out to 9. So we're just going to need a column indicator. It's not going to be a doubling nested loop. It's just going to be a single loop where we wire the row to be 0 and we iterate from 0 to 9 for those columns. So we still have our number of rows and number of columns. So let's just set, hate to declare the variable row because we'll probably want to do it again. I'm going to call it R. That's the row that we're going to set. And then we need a loop. For int column is equal to 0, column is less than the number of calls, call plus plus. And for every item in that row, for 2D at row 0, no, at row R, comma, I could have just hard-coded it 0. Why don't I do that? I'm going to delete that R statement, come back here and make it 0, comma, column. And then I'm going to set that equal to column plus 1. So it'll be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. You know, all the way across like that. Now we can print it out again. But let's go ahead and set the first column as well. Now fill the first column with the values 1 through, you know, number of calls, number of rows. Same kind of idea. We need another loop. For int row is equal to 0, row is less than the number of rows. I'm going to change that comment to say numRows. Row plus plus. And then 2D at the specified row, but only for the first column, is equal to the row plus 1. All right, guys, so we have our array here. Let's go ahead and print it out again. I just feel awfully tempted to go back and copy and paste my code here. So you see this one. For int rows equal to 0, rows less than numRows, row plus plus. For int column is equal to 0, column less than numCalls, column plus plus. Copy that, paste it down here, but let's give it a nice little label up above it. Console.writeLine modified array, just so we have some clue of what we're doing here. All right, and I put that at the bottom right above the bottom of my method with that read key. All right, there we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. It would be real easy to iterate through the loop now, multiplying that by that. Let's do that. Shan't take much longer. So for that, we're going to need a nested loop as well, right? But we're not going to need to necessarily start with 0. We want to start our nested loop at 1, at row 1, column 1. So let's go ahead and do that. And yeah, some of y'all may have figured out that we didn't even necessarily need to set this first one to 1 through 10 and this 1 through 5. We could have done the whole thing in one swoop. But let's go ahead and do it. So for int row is equal to 1, semicolon, row is less than numRows, row plus plus. Same business for column. For int column is equal to 1, column is less than the numCalls, column plus plus. That element 2D at row comma column is equal to 2D at row comma 0 times 2D at 0 comma column.
Why did you start row at 1?
Why did I start row at 1? Because I don't want to rewrite this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I started my row at 0, I would be rewriting those values. Instead, I want to start on the second row.
So you started your...
So I started my for loop at 1. And the same thing for the column counter. I didn't want my columns to start at 0 because I already have data there that I care about.
Gotcha.
Okay. All right, and then I'm going to print it out one more time. console.writeLine, table, whatever. And then I'm going to put my print code in there one more time. So I'm going to copy it again. I should have put a cute little comment, saying that I was printing it. Then I should have done that again when I'm ready to print it out this next time. Anyways, go and grab that code, paste it, and now we're good to go. When we run it, hopefully this will look like a nice little table. Yeah, 10 times 5 is 50. 2 times 2 is 4. 6 times 4 is 24. Okay, that is about enough of two-dimensional arrays. The textbook really does not go into a great deal about it. There is also the concept of a ragged array, where each row consists of a different number of columns. And unlike some languages, the syntax for declaring a ragged array in this language is a bit different. You use 2 braces rather than 1. You use something like this. And then you go forth from there. And I'm not going to cover that. Go ahead and read it. I'm just not going to lecture on it. This is enough for that array, I believe.
Okay. Can you go back to one where you didn't write. Okay, you multiplied those together. You didn't write it the first time.
Right. This is not a print array. This is actually a create table. Create the multiplication table. So we're not printing anything here. We're actually reassigning the value of that element at that row and that column equal to the item on the top row times the item in the first column. And two-dimensional arrays are actually a lot of fun. You could write something that, you could write programs that solve Sudoku problems, or you could, create a maze with a two-dimensional array and have it run through there. Or, you have to figure out how to sum up all the columns of an array as opposed to sum up all the rows, or you could check to see the surrounding, there are 8 values. If you're in the middle of the array, there's 8 squares around you. You can add all those up, or you could inspect them. If you remember the Windows game Minesweeper, all of this is a two-dimensional array. So they're a lot of fun, but I think that's about enough about two-dimensional arrays. Just remember that the number of elements in a two-dimensional array is equal to double that. To iterate through it or to process it, you're probably going to use a nested loop. If you don't care about presenting it in the form of a matrix, you can just print out all the numbers one after the other with a for each. You could say for each int in my array 2D, print that guy out. Console.write, or write line, it's not going to matter which, that value. It was popping up an error, but there really wasn't one. Okay. And so then when I run it, you see that it printed out the entire array, but how did it do it? It just treated it like it was a mega single dimensional array, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, 4, 6, 8, 10, 12, all the way out to 20, 3, 6, 12, all the way up to 30. So you can see what it's doing. If you wanted to print a character turn, a new line at the appropriate times, you could keep a counter, and if it was, the right number of rows, you could print a new line and then reset that counter. But really, I think that nested loops are the way that I want you to figure it out. But if you wanted to write something that summed all the values in the two-dimensional array, the code could be like this, because if you're not printing them out, you don't need to process them as a two-dimensional array. You could just rip through it with a single for each loop, just like you could a one-dimensional array. And this works for 3-dimensional arrays, 4-dimensional arrays, whatever. All right, I think we're pretty good with that. I want to re-broach the idea of parallel arrays, because that's what the homework is going to rely upon. Parallel arrays are when you have 2 arrays of the same length that are somehow related.
Our rainfall program.
And our rainfall program involves parallel arrays. So you could declare an array, you know, something like this. You know, Joe sales look like this, and he, you know, sold $80 the first day, $20 the next day, and he sold $40 the third day. And that's Joe's sales. And then Bob's sales is equal to another array. You know, really I should make that like 7 days or whatever, you know. And on the first day, Bob sold 20, and on the next day, Bob sold 0, but on the third day, he cranked it up and sold 200. Now let's run through those, comparing those. Thematically, they're united by their index value. That's the first day for each one of them, that's the second day for each one of them, and that's the third day for each one of them. So, for int I, for our index value, is equal to 0, I is less than, you know, yeah, I could use 3. That's kind of cheesy. Joe sales dot length I plus plus. And then let's just check. If Joe sales is greater than, or Joe sales at position I is greater than Bob sales at position I, and it's giving me red underlines just all over the place. Okay, they seem to have resolved themselves, right? Then let's print out console.writeLine on day subscript 0, or, you know, placeholder 0, comma, Joe sold more. And let's fill in that placeholder with I. Or better yet, I plus 1, right? So it'd say 1 plus 1, comma 2, comma 3, but I'm just going to leave it I. We're all computer scientists, we know we start counting to 0. Else, if that's not the case, that meant that Bob sold more or that they were equal. But anyways, so if Bob sales, let's keep our same syntax. Joe sales I is equal to Bob sales.
You're in Python? Well, no, you're not in Python.
Yeah.
Else if. You need an else if.
But I do need an if there. Yeah, else if Joe sales subscript I is equal to Bob sales subscript I. I should just copy that line because I'm just going to, you know, type it in again. But let's go ahead and rough it. Console.writeLine. Really wish IntelliSense wouldn't cover up the code that was above it. On day, placeholder 0, comma, Joe and Bob sold the same. After my quote, I'm going to put a comma I, and then after my parentheses, a semicolon. Going to kind of just hang there so that you can get the idea of both of those. And then I need one final else, right, which implies that Bob sold more. Else, and I am going to copy this line. I don't feel like typing it in again. I'm going to copy that first right line that said Joe sold more. I'm going to come down here and paste it. And on day 0, Bob sold more. And I think I'm going to put a comment on my else that says else Joe sales I is less than Bob sales. Now we don't need to actually write it in the form of that if statement, because if those other two cases are not true, then we know that it has to be this third condition. Alright, so when we run through it, it should say Joe sales. Let's make two of them the same though, just so that we get to see all three cases. And there we go. On day 0, Joe sold more. On day 1, Joe and Bob sold the same. On day 2, Bob sold more. And if we go back and look at our data, that's correct. Joe sold more on that day. They sold the same on that day. Bob sold more on that day. So our homework is based on the idea of parallel arrays, but it's more interesting than rainfalls, which you've done over and over in these classes. So let's pull out what the homework is. It's called Orcs versus Elves. I should have opened a PDF. It's taking forever to convert it. My mistake. Alright, I need to change the name of 5B to Arrays. Orcs v. Elves. So, note that this program relies on random numbers. For review, you generate random numbers like this. Random R&D is equal to new random. R&D is our random number generator. When we need a random number, we call it like this. R&D.next, 6 plus 1 generates a random number between 1 and 6. If you didn't add the plus 1 to it, it would be 0 to 5. Now, only make one of these objects. Only make one random object. So don't, in a loop, create a random object and then call .next. You won't be happy with the results. It won't be really random at all. Anyways, that's how we generate random numbers. So, our elves versus our orcs. Write a battle simulator that will fight an array of elves against an array of orcs. So our setup. Declare and initialize an array of 10 ints. Call that one orcs. Initialize each element in the array to a value of 20. This represents each orc's health. They have 20 health points. Then declare and initialize an array of 10 ints called elves. Initialize each element in the array to a value of 20 because each elf has 20 hit points as well. So they attack each other. Each attack is decided by a die roll from a 6-sided die. So you will need to generate random numbers between 1 and 6. So an attack consists of one elf fighting one orc. Each one rolls a die. Whichever rolls higher wins. The loser deducts from their hit points the difference between the die rolls. So kind of like we had here, you know, except we would be calculating the difference, you know. If his die roll was 80 and his die roll was 20, then Bob's sales here would take 60 points of damage. That kind of thing. You get that? So the first elf in the array will fight the corresponding first orc, just like parallel arrays. They both roll one die, damage is awarded, then that match is over and it's on to the next pair of fighters. So orc 0 will fight elf 0, orc 1 will fight elf 1, all the way out to the end of the array. When an elf's hit points is reduced to 0 or less, that elf is defeated. Same for orcs. So a round consists of a run through the arrays where each elf fights each corresponding orc. So you run through the parallel arrays. First elf rolls, the first orc rolls. You calculate which one takes damage unless the results are 0, and then you move on to the next one. Special case. If either the elf or the orc at this position in the array already has a hit point of 0 or less, skip that match. You know, the elf sits there staring at a dead orc or vice versa. When all 10 attacks in a round are done, we want to move all the healthy ones to the front of the array. So sort the array and then reverse the array. That way the healthiest elves will be at the beginning of the array, and all the defeated elves will be at the back. You will know that all the elves have been defeated if the first elf in the array has a hit point of 0 or less. Same for orcs. If the first orc, after you have sorted it and reversed it, has a hit point of 0 or less, then all the orcs are dead. So after every round, not after every battle, but after every one of them has had a chance to display the hit points of the orcs and the hit points of the elves. If all the elves have been defeated, display that the orcs have won. Likewise, if all the orcs have been defeated, display that the elves have won. Repeat again and again, running through the arrays and displaying the hit points of each side until the other is won. Example output. So elves health 2020, 2020, 20. Orcs health 2020, 20. Now elf 0 rolls a 5, orc 0 rolls a 5. So no damage was done. Then elf 1 rolls a 2, orc 1 rolls a 3. So which one won? The orc won. And he won by a total of 1 because 3 minus 2 is 1. So elf took 1 damage. So this elf right here will not have 20 anymore. He took a hit, so he will have 19. And then we keep going, you know, through orc 3, elf 3, orc 4, elf 5 against orc 5, all the way until we have done all 10 of them. And then we print them again after the damage and after the sorting is all over. So we sort them, we reverse them, then we print them out. Here's our current roster of elves. Some of them have taken damage, but since we sorted them and reversed them, we still have a bunch of healthy ones at the top. Same for orcs. So as you're going along, eventually you'll get to the point where a lot of them have taken damage, and you will eventually get to the point where they start off, you know, really, really weak, and then the first guy dips down to 0. The round is over, and the elves win. All orcs are defeated.
Negative health.
Yeah, you could stop the health at 0, you know, rather than letting the health go negative. So note, in this example, the orcs were completely routed. My sample program may have something wrong with it. To double check, I looped it to repeat 10 times. And to count the number of wins, I got that the elves defeated the orcs 6 out of 10 times. You get extra credit if you make your program loop like that, so that you could run 10 wars, you know, over and over, counting how many times the elves won and how many times the orcs won. You can also get extra credit if you figure out something to do with the match when one or the other opponent is already defeated. Say you have 9 orcs left and 10 elves. Why should the last elf remain motionless? Maybe he should take a crack at another orc in line rather than wait his round out. That would certainly make the entire battle go more quickly. Or you decide what he does. You don't have to do that.
I'm gonna spend like 12
Goes
hours
heals
on
his
this
party.
I'm gonna spend like 12 hours on this.
Yeah, so the last elf, you know, or, you know, he goes and he parties or something like that. So anyways, don't feel obliged to duplicate the appearance that I have here. If you don't want to make it look like that, that's fine. But do display the result of each round so that I can tell, you know, that the arrays are changing their values. And I say you could even make it a WPF application if you wanted to. All right, so I'm going to have to edit out the very beginning of this lecture where I said to open that zip file because we didn't use the zip file.
Good question. So when you, I guess, create a random, like a variable with type random, like a new random number, if you do that inside of the loop, both, if you say you have like,
I think I know what you're asking.
well, I'm just saying you define it on the outside of the loop, right? You don't want to do it on the inside of the loop, because if you do it on the inside of the loop and you have 2 values that you want to set to be the next double, won't they be the same value? Well,
It's not that they're going to be the same value, but that it's not going to be seeded very well. In order for a random number generator to work, it has to start with a seed value, because these are just formulas that generate a number, and then it uses that number fed back into the formula to generate another number. And it's called a pseudo-random number, because if you start with the same number every time, you would always end up with the same sequence. So if you put this creation of the object inside a loop, then you're reseeding it every single time rather than letting it generate a sequence of numbers based on one seed. So you might get multiple numbers that are the same value, but whatever, it certainly would not be. And the way those are seeded, or sometimes they're seeded based on, you know, the clock ticks, the number of milliseconds since midnight or whatever. You can set your seed to your own value, which is kind of useful if you want to test it over and over with the exact same series of rolls. But you don't want that in, you know, in your production code unless you want the results to be the same every time. So there is a way to set the seed of your random object of R&D, if you want to force it to generate the same series of numbers every time.
I did, it's because I set the Joe cells and Bob cells to just random, and then compared them to that. I've been doing that a lot lately for testing my code. Instead of, like, if we have user input, instead I would just write like add test values method, and to do that to make sure all the other code was working before the user input, and then just do
Yeah, I agree. When you're writing code that needs to, you know, deal with a series of user input, it's cool to go ahead and just generate random input so that you don't have to type it in over and over and over as you test it. You don't have to type in 12 rain values or whatever. Yeah. All right, so that's enough of that. I think we're done with this for today. Let's make a drop box for our 2D array printing code. And I will see you next time. I believe we're done with Chapter 6.